and molecular recycling is able to just remove the color as well, correct?
Yeah, there's a couple different companies. One in the U.S. is Eastman Plastic, and they break down the plastic down to its base level, and so they strip out any glues, any colors, because they recycle carpet, which goes normally to the landfill, right?
Yeah.
And so they're able to kind of break that down, take all those crazy colors out of the carpet,
take the blood out of the carpet.
Yeah. Exactly.
Hello, and welcome to another episode of Demystifying Cosmetics. Today, we're going to talk about packaging. I know we've covered a little bit on formulation, branding, and even sustainable packaging, but we're really going to look into that perfect combination of formula and packaging and how they come together. We're going to take a look at how brands develop packaging that protects and enhances formulas, and also how you tell a compelling brand story, balancing the difference between aesthetics, functionality, and sustainability while diving into choices brands make in materials, branding techniques, and recyclability. To join us for this conversation, I am grateful to introduce Mr. Alexander Kwapis, who is the VP of Innovation, Design, and Engineering at Fusion Packaging, who are a leader in beauty packaging solutions. With extensive experience in product development, design, and sustainability, Alexander has worked with some of the most recognized brands in cosmetics, driving cutting-edge solutions and launching award-winning packaging. He's also a regular contributor to Fast Company Executive Board and Forbes Technology Council, sharing insights on leadership, innovation, and manufacturing. Welcome.
Hello.
Great to have you on. I'm excited for today's conversation. I'm excited for every conversation. I say that, I think, about every guest, so I need to find maybe some better adjectives moving forward. But
well, I'm excited too, so don't worry.
Great. So, let's start on the basics of how, when a customer approaches you, how you start to explain to them or describe to them how packaging and formula work together. I think that in general, people see beautiful packaging, great. They see or they have a product, they like how it feels, but they maybe aren't as familiar with that relationship between the two.
Sure. Yeah. I think that I would say first and foremost, probably you're going to want to look at like the viscosity of the formula, right? So if it's something, viscosity is like essentially the thickness or sort of how much the formula kind of moves. So, if it's really thick, it's probably going into a stick of some kind, like a propel, repel, you twist and it goes up and down. If it's thinner, it's going to go into maybe a dropper bottle. If it's maybe an atmospheric bottle, so those bottles with a dip tube. So the formula, thickness really directs a lot of what type of package it can go into first, right? I think that's the first thing. And sometimes people want maybe like a glass package. They want a beautiful atmospheric glass bottle, but the formula is too thick. And so then they might have to explore a jar or an airless package that just kind of has a piston that's going to move the formula up as you use it. And so that's why a lot of times you see different formulas in different packages is because of the viscosity. That's definitely a big driver of it. I think also preservation is another one. So if you have different preservative systems in the formula, you might need different packaging for that formula system. So, if it's something that is more makeup-like, it doesn't need to be maybe as airtight. It doesn't need to preserve as much. Yeah. But if you start adding skincare ingredients into things, which does happen more and more with makeup, hybrids, and even it's going into hair and body, skincare is kind of going everywhere, having nice, beautiful ingredients. Because of that, then you might need to preserve the package more or make it more airtight. So formula, isn't kind of escaping through the package as you use it. So, and that doesn't always have to be airless. It can just be an airtight jar. It can be an airtight stick and things like that. So, I would say viscosity and the sort of preservatives make a big sort of determines where you're going to go.
Yeah. Is something that I encountered in the lab recently, and made me think like, oh, well, this is not a suitable package for this product, was not just with preservation, but drying out. So I
Yeah.
had a highly volatile product that I was putting in a relatively, open jar type format. And when you start to think about user behavior, right, you're taking a lid off, you're going to have material that's going to evaporate over time. And so I walked into the lab 2 weeks later and I was like, what is this hard thing?
Right. Yeah.
And
Yeah.
so, that is an element too that people have to think about, is that customer journey, right? And how they're going to be using it in what format. You mentioned the preservation. So for instance, if somebody is making like a body wash, are you going to be advising customers to, think about, well, that's a humid environment, right? And they're going to
Yeah.
be probably introducing more water.
Yeah. Or maybe you want to make sure that, let's say it's in your shower. You want to make sure your pump engine, is waterproof, right? So it's not allowing water back in, or that the spring inside won't rust, right? So there's different types of materials we can use to make sure that we're going to not have a rusty spring inside there.
Yeah.
And then, if it's maybe a disc top or something that's opening and closing, you want to make sure that it's going to seal nicely. For sure, I think ingredients it's a big reason to kind of choose different packages. Isodecane is a good example of an ingredient that has kind of flashes off as you use it.
Yeah.
And so if you're constantly opening the package, like you're saying, you're going to kind of lose that formula, the ingredient, as you use it. Sometimes even the formulas kind of go through the walls, and so. You can even choose like barrier properties. So maybe a bottle that has multiple layers to kind of stop oxygen kind of escaping through the package.
And is there a consideration, or have you observed incompatibilities with, let's say, raw materials as well as packaging?
For sure. I mean, definitely. We always suggest doing compatibility testing. You're done it not just like in a glass jar, more suitability, but actually in the package to make sure that you don't maybe get the formula might be escaping, and you'll start to see maybe the paneling happening. Mm-hmm. So the formula is the bottle maybe is sucking in as the formula is literally sort of secretly escaping through the walls of the bottle.
Interesting. Okay.
It does change the formula itself because it's losing maybe water or it's losing some other ingredient that's escaping, and maybe it's becoming more concentrated and things. So definitely have to think about compatibility for swelling the opposite way. So it could suck in. It could also sort of bloat, and that might be the formula isn't interacting negatively with, especially soft materials can do this. You might not notice it maybe on a tube as much because it's flexible and kind of you don't notice the shape as much. But on a bottle, you'll see that sometimes where your bottle over time will start to sort of expand out. Yeah. And that's definitely bad. There's something happening and maybe causing gas in there, and it's maybe swelling the material and softening it. It's not great.
Yeah. And this is a little tangential, but it makes me think about, the differences in food versus cosmetics. But I did a project once looking at can liners for carbonated beverages. And something that we needed to evaluate was what was called flavor scalping, right? So the ability of that liner to take certain, whatever components were in that flavoring and alter them. That's not something we do in cosmetics, right? We look at weight loss, we look at, does it change colors? But at no point are we looking at the profile from like an analytical chemistry standpoint, or even microplastics,
Yeah.
Do you think these are areas that cosmetic products should be looking at? Or, because it's a relatively low ability to absorb into the body, you're kind of like, well, we'll see.
Yeah, I mean, I do think that you should be looking at the overall experience over a period of time to make sure that your formula has as good of an experience on day one as it does at the end of the package, to make sure it's not discoloring. A lot of times that maybe happens with vitamin C. You get maybe not flavor change, but discoloring, and retinols also can sort of lose their strength over time if they're being reintroduced to air. So it can happen. And I think as we're exploring, new ingredients, I think it's going to happen more often for sure.
Yeah. Okay. You can think of like iconic brands, right? Where you have one kind of image of when you say things like Chanel, right? Or, I can't come up with another example right now, but these really iconic beauty packagings that, stand out. What makes for those iconic brands? What elements have they captured that really have just, it gained such mass following?
Yeah. Yeah. I would say, I think when a brand really hits on sort of this package, if the package or the lineup of the packages from far away, if you can look at them and say, that is, whatever brand, that is a road skin brand, right? Or this one over here is Chanel or MAC or whatever brand you choose. Like, the brand has looked at the essence of the brand and tried to sort of solidify that into the physical form of the package. That's really what packaging is the essence of the brand in physical form. And when it's on the shelf, that is sort of the first engagement that you're really getting in a physical format. Maybe you before have pictures and you have a vibe or a mood through social media or advertising. However, once you get in the store shelf, that's really sort of the part that starts to take over. And you want that item, that package, to feel unique to the brand. And there's a variety of ways that you can do that.
Let's go into those.
Sure.
So, right, we have on here, and this was something that came up in our initial conversation. And you live in this world, and so you were throwing out things like screen printing, and I was like, I feel like I've used those terms. I don't know if I've used them correctly. Yeah. Luckily, they haven't been in conversation with people that maybe would know the difference, but I am very interested in kind of you walking us through a little bit of how brands can customize and create, consistency or branding within these elements that, you may say it's a tube, right? Again, or atmospheric packaging, right? It's not a lot you can do in terms of creativity in the basic form. Take us through it.
Yeah, I think some brands start off with trying to use as much as possible, maybe similar shape elements. So we'll get into deco, but first I would say shape, right? So you can customize packages or find stock packages meaning your supplier already has a set of molds that are made so they can produce, let's say, a bottle or a jar in whatever size and shape you want. But a lot of brands, it's hard. Even let's say the Chanel shape has that unique sort of square that's got the sort of bulging corner or sides to it. I think then you'll look next to it and there's another bottle within their lineup that's round, right? Because not everything always can be sort of a unique shape. All brands sort of have to have a mixture a lot of times of custom shapes and stock packages because of timing or price. And so decoration then allows you to unify all those packaging parts to make them feel cohesive. And you were mentioning Silkscreen. I think that's one of the most popular ways that people decorate items. That's really where your artwork is. So Silkscreen is literally done by a screen. So think of like your screen door at home. It's a screen similar to that. And you, at the factory, will burn the image of what you want. So the letters and things and all that. And then we use ink that's sort of like a squeegee is applying the ink through the screen and it gets pressed onto the bottle or the package, whatever it is. And then we use UV light typically to harden it. And then that's there. It's directly printed onto the package. And there's a couple different other ways we can do direct printing.
Do you know why it's called silk? Was this previously like a method that was used on silk?
I think it was originally like silk, mesh, basically. Yeah.
Okay. It sounds very manual, but I'm sure there's been some automation. Well, not some. Totally. There's been significant automation in that, right? Okay.
Yeah, there's automation, but it's similar general process of maybe you might get a T-shirt silk screened or something. Yeah. And you might see that at a shop or something. It's the same basic idea, but it's just automated these days. So the bottles are kind of spinning as they go down, and there's a squeegee that kind of auto moves, and it's very cool actually process to see.
Yeah. And I assume then because it is moving bottles, then this cure, it has to have a significantly quick cure rate so that it doesn't transfer. And then longevity in terms of, it's not going to wipe off when, or crack when you drop it. So all of that testing probably needs to be done in terms of the colors you're using. And
Yes. Yeah, your supplier should be doing maybe a tape test to make sure that it's, with sort of using standard tape to kind of make sure that it's not being peeled off. It's a nice sort of standard way of testing. You should always ask that. And I would say you can tell if it's silkscreen if you can kind of feel it. If you kind of scratch your hands over the package,
it'll feel like
and you hear
rough.
that scratching sound of like that surface change,
Yeah.
that's silkscreen. You can also do hot stamping.
Okay.
So that is flush. So if you ever sort of scratch and feel it, it's like flush with the bottle. It's thinner foil. So it's essentially a thin piece of metallic foil, but it can also be done sort of painted. So it's like a color, black, white, blue, whatever. And there's some adhesive on the back of it. And it basically uses heat and pressure, hot stamp, to apply it to the package. So if you see a lot of times, a compact with that gold embellishment on it, that's hot stamped, and that's another direct application.
And so these all fall under direct deco?
Yeah, I would call these direct deco. Yeah, and you can also do heat transfer label, so it's kind of similar to hot stamping, but instead of being just like one color or one foil, you might apply multiple colors separately in sort of a flat foil, roll it all up, and then apply it at one time. So it's nice if you want like real good tolerance, so you don't want things like moving around too much if you have a lot of different colors and things of that nature. But it's difficult if you want to change the artwork, right? Because you have to kind of do that separate and then apply it.
Is this the same process that is also used not just for, let's say, logos and text, but if I wanted to take a clear bottle and make it green?
Could, probably not though. So yeah, no, good question. So a lot of, so that's just more of like artwork deco, I would say, what we've been kind of discussing, that direct deco. And then, if you want to, let's say you want to make it green, I would probably do either inject it the color. So when you actually mold the part, it can be molded a color. So that's like one option.
Is that just for plastic though? Can you mold glass in colors?
You can mold glass, but most glass companies are only making clear bottles these days. They don't have, because there's essentially like a big molten lava furnace that has the sort of liquid glass.
And once you color it, then that's the next phase of your business is that color glass.
Right. Yeah. So you have to kind of have like large quantities. That's why you might see amber glass, maybe in some beer bottles or maybe some apothecary items. Sometimes there's green, and then clear is the most common, and I would say most of them are green or clear. But if you want a glass or if you had an injected bottle and you want to decorate a color, you could do sprays. So you can spray it a color and you can make it opaque so you can't see through it at all. Or it can be a translucency so you maybe see some of the formula through the green color, let's say. And that can be done to glass. It can be done to plastic parts. And it can also be done glossy or matte. So you can apply like a matte finish to it. And that matte finish doesn't have to have any color. It can be totally, clear, but have that sort of soft blurring effect on it. Or you can metalize it. So if you wanted to go even, still sort of an application applied to the bottle or jar or whatever, you could do a metallization process. So essentially metallization, you sort of like, think of it like painting. You're going to put a primer coat. And then you're going to put it into a chamber that is going to have like metallic particles stick to the part. And then you put some sort of clear coat on it or a colored coat. So if it's like a metallic blue, it would actually be silver underneath and then a blue translucent finish on top.
And, all of these capabilities, are these things that are very, are they unique to one facility and then you have to transfer it to the next in order for like the next step to happen? So if I wanted, let's say, a green glass bottle, silk screened and then metallicized and then silk screen, am I looking at having to engage with 3 different vendors, or is this something where, you have a one manufacturing facility that can do it all?
Yeah, it depends on the facility. So some facilities are very vertically integrated, all in house. We have our facility has metallization, has the injection as well, the silkscreening sprays, hot stamps. I would say most places have probably at least silkscreen and hot stamp. The spray, they might have to go out of house for if they don't have the facility that can do that safely and pass all the sort of safety checks and everything.
Yeah. And what does that do for sustainability and recyclability? I know that's always been something that I've heard, but not fully understood of, if I want to turn plastic blue, does that now not make it curbside recyclable?
Yeah, this is where it gets kind of tricky. This hasn't been tricky so far. The recycling, it really depends on the material. So if you're doing, let's say polypropylene parts, you might see PP, or number 5, if you're looking at the little triangle, or PE parts, polyethylene parts. So maybe like let's say a milk jug, or shampoo bottle. Those are usually HDPE, which kind of falls under this, polyethylene family. Tubes. So you can inject those a variety of colors. The darker the color, the sensors at a recycling center might have difficulty reading what material it is.
Okay.
Because basically the color and the material has a wavelength, and sort of the cameras can detect based on the color and the material what it is. If it gets too dark, then you might have to add, it's called like non-carbon black to it. And you can do testing. So there's companies like the Association of Plastic Recyclers in North America. They will do testing if you want them to understand sort of, if your items will be recycled. If it's PET, it's pretty black and white about what you can do. So PET is sort of the most universally recycled material. Polyester, think of like your carpet, maybe your sort of fleece jacket. Those are all polyester, and PET, water bottles, soda bottles, those are all PET. And everyone kind of wants clear.
Yeah.
Like that light blue kind of color you might see in Evian or Dasani bottles.
Yep.
And then sort of like a translucent green, you might see like Mountain Dew or 7-Up, something like that. That's really your 3 options for recyclability for PET, as far as color goes. And those have to be molded into the plastic. If you start applying sprays or metallization or even deco on PET, it starts to make it not recyclable. It could be recycled, just there's not a market for it. No one wants it.
Yeah, like it only can be that color for the rest of its existence. So
yeah.
Okay. And then what about glass?
Glass, I would say, glass, it really depends on the area of what they're going to take. Most of the time, they want clear bottles. Same thing. They will. There are places that will take back colored glass and decorated glass and burn it and heat it, and then it. A lot of times when you have direct decoration on recycled components, it might make little black marks, right? You might see that sometimes on recycled parts. That's what that's kind of coming from, is from maybe some of the different decoration elements. I think amber glass is really hard to recycle. I don't think there's that much recycling for that. Everyone kind of wants clear because they want to make it back into clear.
Yeah. Okay. Good to know. Can you walk us through, let's say I approach you and I say, I've got this product, let's do packaging. Can you walk us through the processes of kind of how it starts to it's on the shelf?
Yeah. First, it's really important to understand, what your timing is, right? Because there's timing. If you have more time, you want something custom, then you have more time to do that. If you don't have as much time, then you're probably limited to stock packages. So that's I would say a first factor. And what's the formula? Like we talked about viscosity and preservation and all those type of sort of formula aspects to it. Once we kind of narrow that down, I would say understanding your price point too, right? So if you have if you want something that is more decorated and it's unique shapes, it's probably going to be more expensive, maybe thicker walls, things like that, because there's more resin, more plastic in there. Those things are going to be more expensive. If it's something that's a simpler design, let's say like a dropper bottle or a jar, those are going to be kind of on the less expensive end of things. And That can vary a lot based on material and quantity. Higher quantities, your price point might go down a little bit, and then the decoration also affects that. So that can be, I mean, the range is huge. It can be 30 cents to over $2. It really depends on a lot of factors within there. So understanding maybe a benchmark of a packages you like, that makes it easy for your supplier to start to say, okay, this is the cost and things like that. Based on some similar items that you have. Once we kind of identify packages, then it's starting to test really, we want to test your package with the formula to make sure that everything's going to go well. So you might, if it's a spray package, you want to put the formula in there and see how it's going to spray, right? To get that spray pattern. Yeah. If it's in a pump, you want to see if it's going to spit out or if it's going to clog or if it's going to swell something or if it's going to come out without any issues. So the testing component is really important. And we even like to do testing with deco. So we decorate the package.
I was going to ask, is there like standardized tests, like an ASTM test, or I've heard drop test before, right? Transit test. Are there industry standardized tests that would occur during this kind of evaluation phase?
Yeah, and so we have most suppliers have different packages with different. They can specifications or specs, right? So different packages can drop different heights. It might be as high as 76 centimeters. It might be, something very low. It just depends on maybe the materials. It depends on the design of the package. And I would try to understand if this package is passing standard specs. You can always ask what the specs are, what the pull-off force of the cap is. We talked about drop height. How many pumps does it take for the formula to start to come out? That's really important because that kind of affects the user experience. You don't have to be
And are those adjustable? I know, for instance, on a deodorant stick, right? The elevator height is adjustable. But if I was I can't take 16 pumps to prime this thing, is that an adjustable feature?
It can be. So a dip tube package that has the tube coming down, the formula is at the bottom of where the pickup is. And so you're really just looking at how long it takes to kind of get its way up.
Like dip tube length, right? That would be the adjustment. Okay.
Yeah. If it's really thick formula, it might not be able to make up the dip tube. And so then we might say, hey, let's put in an airless package. And then you have to make sure that you fill it high enough that the little pickup for the tube is in the formula when you put it on, right? Yeah. And so your suppliers should be working with you and your CM to contract manufacturer for the filling of the formula to make sure that you have good harmony of the package and formula, and testing to make sure that there's no issues with evacuation is another important one. You want to make sure that you get more of the a certain percentage of the formula out.
Yeah, I absolutely hate when you get the dropper tubes, and then there's that little bit of the formula at the bottom that you just can never get.
Yeah. Dip tubes have the same problem. Anything with that little tube, you're gonna, a lot of times, we do a lot of airless at Fusion, but we also do other atmospheric pumps and droppers. And usually droppers and atmospheric pumps, you're leaving about 20% of the formula in the package.
Is there no better technology yet to just extend that a little bit further?
The solution usually is airless, right? And because you have that piston driven that's pushing it all the way up to the top, you'll get close to 100% out. It depends on the viscosity, the thickness of the formula, but sometimes the bottles can be shaped differently. So you might find a stock bottle or make a custom one that's shaped so it kind of brings
concave or something.
Allows the formula to kind of catch. Or you can play with the dip tube too, so making sure the dip tube is not too long, so that it's actually able to kind of get all the formula out. It is a pain, but that's why a lot of times droppers and atmospheric bottles, those are all thread off usually. Yeah. And so the expectation is you're going to kind of shake it out, which is not a great user experience.
Okay, real quick. Raise your hand if you have dealt with active instability. If you have ever opened a jar of retinol cream and smelt an off odor or noticed your formula went dark brown, chances are you are dealing with active instability. It's never fun when the formula you've been working on goes south and the due date is only days away. That's why we've encapsulated the trickier ingredients to work with so you can kick the stability struggle to the curb. From retinol to vitamin C, we make it easier to work with those ingredients that typically give you that 3 p.m. headache. The cellulose shell shields the active, from outside exposure. You know, things like air and light that are likely to cause active breakdown. Giving you the power to create stable and effective formulas without the trial and error. Ready to quickly create effective skincare formulas? Discover Tagra's Cellucaps line by going to tagra.com/cellucaps. So, have you encapsulated yet? Now back to the show.
So walk us through, I'm interested in the process for custom packaging. Let's say I've got an idea, we can't find it. I have identified a loose drawing of what I want. What happens next?
Yeah, for us, I mean, I manage our team of industrial designers, so we'll look at what you're sort of envisioning, right? And then we'll build around sort of, around a system. So, some sort of pump engine, let's say, if we're using a dispensing package, or if you're using a lipstick, let's say, we build around an existing elevator piece, that part that kind of goes up and down, the propel, repel part. And we'll build unique shapes around those parts. I would say, not too often because it gets very costly and takes a long time to build, like from the ground up, a full new pump engine or a full new, propel repel stick or something. But building the fashion parts around it isn't as complicated as building sort of, from scratch. And so we'll come up with a bunch of ideas. We'll share them to you. We'll do rendering, see which ideas you like. We'll tell you maybe the pros and cons, which ones are more sustainable or less sustainable or different features of them. And then based on sort of your needs, we'll make you kind of maybe narrow down some options. A lot of people make prototypes so you can sort of see it in physical form.
And how is that done? Like, I assume you're not just like 3D printing, like, here you go. How are prototypes made to have physical product in hand to try out?
Yeah, we like to really make prototypes where we're using some existing components so that you can, let's say it's a lipstick, let's just say, then I would, build it around an existing system so that you could, if you wanted to, put a lipstick into it, maybe an actual bullet into the package. And then we'll print prototypes. We use SLA machines, so stereolithography. There's a variety of different machines out there. They're all good. They all have different sort of pros and cons. And the end result, though, for all of them is that you have some sort of physical part that's been built up and made. And it's really nice. Sometimes if you want just overall feel, it might be fully solid, and you just want to get an idea of the proportions of it. It is nice, though, if you can put it in with something existing and then actually get a true user experience of it. That's definitely nice.
So let's say, I like what we've done, I've like what you printed, and now I want to see it in mass. So what are those steps in between?
So a lot of times when you're just doing the design portion, that's true design. That's no matter if you're with your supplier or even out of house with a design agency. The next step really has to be engineered. And so that's where we're going to look at actually drawing up each individual part as well as the interaction of all the parts. We're going to identify what the specifications are. A lot of times we'll just do we'll kind of write down what the risks are with the different designs as well. So we can kind of make sure that if filling is tricky, we want to make sure that we talk to the filler to make sure that there's no issues with filling or whatever it is. And then from there, we'll also get final pricing and make sure that we're aligned on how much it's going to cost, as well as the mold cost to make the molds themselves. And then once you're okay with everything, then we actually buy blocks of steel and start cutting them away to make the shapes, and then refining it, and that takes it takes weeks to kind of go from I want them saying yes, the cost is good, the design is good, let's go forward, buying the steel, cutting the steel, and then you go through a process called validation, which is basically making sure that all the parts work with all the cavities. So you might have a mold that has I like to think of it like I'm making muffins, right? So a muffin might have 6 little cavities to make muffins. Molds are pretty much the same idea. And so you want to make sure that the cap from cavity 1 works with all the other cavities of the collar or something. So you have to cross match, do all this matrix testing. It's complex. But basically, we're making sure that in all combinations, the package is going to work to the specifications that we put together. And we'll go through that process and make sure that everything is all ready for production. Usually at that time, then you'll do a pre-production order. And so what that means is you're going to have the final artwork ready, colors. We'll actually inject the parts, the actual parts, decorate the parts. It's a smaller run to make sure that we're aligned on, what it looks like. And then we go into production once everything's all set up.
Okay. Walk me through a typical timeline for that, because it seems not short.
Yeah. Usually the let's say before making the molds, so like the design phase and the engineering phase, that can be as short as maybe, 2 months, a month, 2 months if it's something stock.
Yeah.
It can be longer. Usually it's the brands sort of that takes longer because you're making there's a lot of different stakeholders and you're trying to figure out, again, this is the physical manifestation of the brand. And so I get it. It's very sort of hard to be like, yes, this is the final shape we're going to go forward with. Right.
Yeah.
And so that process, it's like a funnel. It's a funnel of a lot of ideas. And then you narrow down the ideas, you make some prototypes, you narrow down more, you make engineering drawings, you narrow down further till you're ready to kind of go. So that can take, 6 months. It can take 2 months. It kind of just depends on some of those factors. But I would say on average, it's probably 3 to 4 months if someone kind of has an idea of what they really want and you're kind of just going through the finalization of the parts and testing maybe beforehand.
Yeah.
And then mold making, it depends a little bit on the molds, the different types of parts you're making. But I would say on average, it's maybe 3 to 4 months to buy the steel, cut the metal, and validate all this cross matrix, all the different parts to all the other parts to make sure that everything is going to be ready for production. That's about, maybe 4 months. And then maybe under a month for your pre-production test, pre-production samples, maybe a month or something like that. If you're on location, so if you can go to the factory to help with validation or help with the pre-production samples, because you might make tweaks to colors and things. That makes things faster for sure. That can be hard to do though if you're manufacturing in another country.
Yeah.
So there's always that. But some people have teams in locations so that they can kind of help speed up that process. And then the production process just depends on your the quantities that you're running, right? So that a production order for a custom project, might be 500,000 units. It might be 100,000 pieces. It can kind of, vary to whatever extent you want. And that's going to take, weeks to kind of run and get out the door for you.
Okay. And I think that leads nicely into something that we discussed, and I read an article actually in Forbes that you wrote about. I think it's very timely talking about steel, right? There's been some newly or soon to be implemented steel tariffs in some of the work that I'm even doing with project management and product development for a candy company who outsources everything. I wanted to talk about, kind of the state of play in terms of packaging, especially when we think about cosmetic packaging, right? China is a huge player.
Yes.
And you and I talked about a little bit how people have villainized, I think, the role of China in, having these capabilities. But the reality is that they've built significant technology and a lot of economics because of this. And so really wanted to have you discuss a little bit of, what the differences are between the capabilities that we see domestically versus, why things are predominantly sourced in other countries.
So Fusion Packaging is part of Aptar. We actually Aptar has manufacturing in North America. It's one of the few packaging companies that has manufacturing in North America, but it's of limited options. And other people do too. There are also limited options. It's, if you think about it, if you're just making a blow molded bottle, that's easy to make in North America because it's one mold or, set of molds. And you're kind of not doing a lot. It's maybe not a lot of parts to it. It's not very complicated per se. If you're doing maybe an airless system that has 7 parts just in the pump engine, and then it has another maybe 8 parts in the rest of the package, they're uniquely colored because you want to match your brand colors. It's been direct decoed. maybe metallized and sprayed and all these sort of, different things to make it feel very unique and beautiful. That's all done, mostly done in Asia, a lot in China. I mean, if you moved all the just cosmetic business of China to North America, it would overwhelm by far. I mean, there's no, the manufacturing footprint in North America is just not there for a lot of the unique packages that we're running, as well as if you're running large quantities for maybe like personal care or food and beverage, there's a little bit more locally made options. But if you're doing unique bespoke items, even unique to you lipstick, and you're running 50,000 pieces, that really has to be done in China and in Asia in general. I think we do manufacturing in Taiwan, there's South Korea, a little bit in Asia Pacific, but mostly in China. And I think just as US has outsourced, and even Europe has outsourced beauty products, beauty manufacturing, it all really settled in China. And they have, the resin suppliers, they have the decoration, they have the manufacturing, the mold making, even US manufacturing. A lot of times the molds are made in China. So then there might be that cost of bringing the steel in.
And that's one element. But what else is there? Is there that lack of, educational foundation, like, going to college specifically for something like an engineering trade that is, specific to this? Why has everything been outsourced?
Why is everything? Yeah, I mean, in the United States, we have some really good package engineering schools. So Michigan State is a great example where a lot of engineers come out of for our industry. But as far as manufacturing process engineers, there's so much of that has been, since the 80s and before, has been really moved over to Asia. And then China, I would say, has just really taken on technology. I mean, people probably a lot of times think that there's just a lot of humans assembling their products, but there's not. There's actually a lot of automation. And so there's a lot of school, a lot of education, a lot of tax incentives on their side of things to help the manufacturing companies, advance. I mean, I go to factories now and there's little robots driving pallets around. There's robot arms that are automatically checking molds and testing parts to make sure that they pass the specifications. And you have maybe a team of people managing, sort of a fleet of automated robots instead of individual people assembling, in an assembly line format. You don't see that anymore.
Yeah, and I think that's the misconception, right? A lot of people are like, oh, well, it's cheaper because they don't pay livable wages. Yeah. It's like, no, they've automated it. That's why it's cheaper.
Yeah, it definitely used to be more that way. Chinese New Year is a big holiday in China. So it's kind of like in the US when everyone travels for Thanksgiving or Christmas. So everyone would, a lot of people kind of come to the coast for manufacturing and then go see their families, maybe someplace else. And so there was this brain drain that would happen as people would leave, and then the holiday would be over, and maybe not everyone would come back. And so the factories in China have really worked hard to make automation so that they don't have that issue with the supply chain, with the people, and they have more knowledgeable people that stay, that are managing more complex things like automation.
Yeah. And I guess for brands or individuals that really are pushing for domestic sourcing, what lessons can we learn from China's approach to cosmetic packaging production?
I mean, I would love for us as a country to invest in manufacturing, invest in trade schools, education, the supply chain of bringing things back. Even just like the cost of land is more expensive here than in other places. And so even just like the square footage of building a factory is expensive. So we need to think about it very holistically, because the options that are in North America are very limited. And so you have to then decide, do I want to have a more simplified product lineup that maybe, is similar to what other people have, because there's not as many options.
Yeah. Let's talk about innovation and leaning into a little bit more, I guess automation is one thing in terms of manufacturing, but in terms of, I think, aesthetics or, trends that you're seeing, what kind of are some of those emerging shapes to trends that, or even, really cool things that you're like, we didn't think we could do that before, like create a dropper that gets all the product out.
Yeah. I would say, gosh, probably 5, 10 years ago, there was a lot of new innovation that was focused around unique experiences with specialized materials, kind of creating those different experiences. So you might have like a flexible TPE, button, and the packages were made up
Oh,
of
like
more
that, like
material.
haptics of
Yeah,
a package. Yeah.
yeah.
Okay.
And as we've gotten more sustainable, we've kind of moved to basically polypropylene, polyethylene, and polyester. So PET, PE, and PP are like really the three main workhorses now, because of sustainability. And so I'm seeing innovation of companies kind of minimizing the types of material mixes to make them sustainable, and doing really interesting, unique things through the design and the molding of it. You still can have really beautiful experiences, haptic sounds, clicking and snapping,
Yeah.
and things like that. But we're doing it with these sort of limited material options,
Got it.
which is
Yeah.
really interesting.
I think there was a conversation I had once with somebody that was supplying one of those like alternate plastic forms where it's like, well, we can't do a living hinge with this, right? Like the limitations to,
Yeah.
so, previously some materials. And touching upon, your mention of sustainability, you and I had a conversation about kind of these emerging, new materials, whether, PLA is kind of not anymore new, but some of these other ones that maybe are microbial derived, and, advertise themselves as being compostable, which, probably poses problems when it comes in contact with anything that has water, carbon, things like that. But how do you view sustainability, and what, is your advice, or, what you believe to be kind of the best selection process?
Yeah, I mean, I love the idea of compostable items, but with our formulas, I mean, it's great if you have it as a secondary package, right?
Yeah.
A box that can be compostable. That's a great solution. Especially compostable really should be compostable in your backyard, compostable, not
Yeah. Not
compostable in sort
industrial
of
compostable. Yeah.
non-industrial. Yeah. Compostable items sometimes can negatively impact recycling, right? So if it's clear and it's industrial compostable, people might think that it might not realize that it's not polyester, and it's not PET. And so those items can go into the recycling system and maybe negatively impact the recycling of plastic goods. And ultimately, I don't think we're ever going to get away from plastics. It sort of serves so many purposes. What we need to be doing is making sure we're making packages that can be circular, so that they're made of recycled material and they can be recycled, right? You don't want to just have it be linear where you use it one time and it just goes in the trash. You want to be using items that can be reused as plastics, ideally at the same level, not downcycled, maybe to a park bench. That's not as ideal. And that's why there's some of these limitations we discussed earlier about colors and printing and things. So that
And is there like a finite life for, like, from what I understood, again, I shouldn't even say from what I understood, because that's very little. But plastic, once it's recycled, right, there is like some loss and degradation over time that it then becomes not usable. Is this correct?
Yeah, if you're doing a lot, yes. Depends also on the plastic, right? So if it's like ocean-bound plastics, those you probably are going to get one, maybe two more uses out of them, and that's it. We can use 100% recycled polypropylene, for instance, in bottles, and we run in the same molds that we run, non-PCR, non-post-consumer recycled plastics, and it works great. Now, we make sure that we're using really, really good material. So that's part of it, of course. And I think what's coming online more is we've been mostly talking about mechanical recycling, which is, you use it, it gets washed and ground up, and then basically gets used again. Yeah. There's also a new technology. It's called molecular recycled. And it basically breaks the material down to the sort of the initial ingredients of it, and then you can build it back up. And you can do that infinitely. So just like metals and glass, with molecular recycling, you can recycle infinitely.
Nice.
And so I think a lot of times people are just thinking mechanical recycling has a limitation. And I don't think we're there yet. We don't have that. People aren't recycling enough to even worry about that. I would say recycle more. We'll worry about that, and we can always transition to molecular recycling, which is starting to come on for multiple materials.
And I think that highlights something that I had, I think, difficulty in looking at PCR, that post-consumer recycling products, or post-consumer resin.
Recycled resin.
Was there, at one point there was a shortage. And is that, why does that happen if we are producing so much plastic and it can be manually recycled now? Why has there been an observed shortage at times?
I think that there's, first off, the recycling, having the material in the first place requires us as consumers to recycle, right? Yeah. And so you first are relying on people recycling in the first place. And then also recycling is actually a marketplace. And so there's actually sort of the price of paper or the price of glass or polyester or whatever goes up and down based on the usage. And so it's just like, again, it goes back to the circle, right? So if you're using PCR in your plastic parts, you're going to drive sort of the need for it. And if there's a drive for more need for it, then some companies are going to come on board and increase supply. So they might be taking back. And then if there's not enough money in it, they might hold on to it. I think some places maybe even throw it away if there's sort of not a market for it, because it's truly a marketplace. And we as consumers have to make sure that we're actually recycling the right things so that the MRFs, the sort of recycling places, your local recycling places, they're not having to sort of sort through, tires and wood and stuff that doesn't get recycled. You want them to be sort of efficient as possible. Your taxpayer dollars also usually pay for those things. So it's worth it for us to, use that. We haven't experienced any shortages. But I think it depends on what type of PCR you're using and then what is sort of the market for it, for sure.
How successful do you think programs like having the deposit on aluminum cans, right? You pay 5 cents up front, you get it back if you recycle, would be for plastic?
I grew up in the Detroit area of Michigan, and so we had 10-cent deposits, and it works. I tell you, everyone recycles, their cans, their bottles. Even if you go canoeing, you're going around in your canoe and collecting them from the river or whatever. It's just everyone recycles those things because you've paid for it, because you paid for it up front with the deposit. So you want to get that money back. And I do think that could be really, really beneficial to driving recycling rates. I think also, of course, you would think that having recycling at home would be one of the easiest options. I am seeing, companies like Pact, they're putting sort of bins at like Sephora's so you can kind of recycle things, and recycling things that also might not make their way through the recycling system. So your lipstick, even if it's 100% polypropylene,
it's too small, right?
Right, in North America. So some of these other sort of ways of recycling, I think, is really beneficial.
Is there an opportunity there then, you think, in terms of, synergistically working, like packaging with recycling facilities to be able to take that lipstick and say, do something like molecular recycling where you're like, well, it doesn't matter the size of it, I'm breaking it down to monomers.
Yeah, I mean, a good example is I think Pact is actually taking back colored polyester, so colored PET. If you want a light translucent pink toner bottle, and you want to put your deco right on it, you have to have something like Pact to kind of recycle it. And they're using molecular recycling to actually be able to recycle those things that normally curbside would not be able to be recycled.
And molecular recycling is able to just remove the color as well, correct?
Yeah. Yep. So there's a couple different companies. One in the US is Eastman Plastic, and they break down the plastic down to its base level. And so they strip out any glues, any colors, because they recycle carpet, which goes normally to the landfill, right?
Yeah.
And so they're able to kind of break that down, take all those crazy colors out of the carpet.
Take the blood out of the carpet.
Yeah. Exactly.
Nice. That's interesting. Great. Well, I think we're coming up on time now. And, is there anything else that you want to share, or something that you found surprising in your career in cosmetic packaging?
We were talking about innovations a little bit earlier, and I would say what I see more and more happening is, there's a lot of clean ingredients, right? And I think because of that, companies are really working hard to create really innovative, sustainable, maybe EcoVadis, which is like sort of a sustainable rating company. We're creating, people are creating these formulas that sort of meets both sustainability needs. They do amazing things for your face, and they're really hard to package a lot of times.
Yeah.
If you think about, your face can regrow, but your package can't. And so I'm finding more and more amazing formulas, and really having to use more and more unique ways of packaging them. So maybe like multi-layer bottles, airless systems, unique ways. So I think that there's a lot of opportunity for brands to sort of explore these unique formulas with unique packages, that I think more than ever, for sure.
Awesome. Well, if any brand is listening and they want to explore new formats, Fusion Packaging and Alexander, that's their go-to.
Yeah.
Well, great. Thank you for today's conversation. That was wonderful.
Yeah, thank you.